So I will just give a key messages, but I have a lot of slides, so you can share, and if some people want more information, you can help me. So just an overview. What I know, maybe all of you know the nature-based solution. Basically, there are a lot of natural systems that reproduce what happens in the nature that can remove pollutants, and we can make use of it to treat all type of wastewater, from zoo wastewater, grey water, wastewater, etc. There are water-based solutions, ponds will be, and the ones that are based in the mechanism of natural wetlands and the treatment wetlands or constructed wetlands. About here you have photographs. All these natural-based solutions can work. So we are focused because we work on treatment wetlands, but there are other natural-based solutions that can work also. So let's have this in mind. And they can be used, that's very important, alone, combined, because they do different things. So maybe depends on the pollutant, we can combine these treatments. With technology choice depends especially in the inlet water and in the outlet water. And this is also for the constructed wetlands, depending on the quality of water we have and the quality of water we want to achieve, we can use another kind of wetland. And the availability of land, that is very important also. Okay, for the constructed wetlands, you know, there are different types. Basically, I don't know if all of you know, but basically wetland, what have is like a pond, like a swimming pool at the end with some gravel, no, some media, some sand, and some inlet and outlet structures for distribution of water and some plants. And this is it. It creates an ecosystem that, depending on the oxygen condition, can eliminate one thing, pollutants or another. There are the free surface water surface that occupies a lot of space, but work very well and also creates a good habitat. And there are the subsurface flow that the water is underneath the gravel, so we don't see the water. There are horizontal, vertical, and there are hybrid that combines both. This is the passive system. Then there are now, some years ago, it's like the irate system, that I mean that we put like something mechanical. So to make the system works better with less space. And this is the subsurface flow, and we go direct to the vertical. Well, the important criteria, what have the subsurface flow system? We have the inlet quality, the media is very important, the plant and the temperature. With these four parameters, we can design these systems. The media is the key parameters, is the most important thing. If we choose a good media, it will work. If we choose not good media, it will not work at all. It's more important the media than the plants for subsurface flow. This is my key message. So it's very important. The plants are important, but not so much, like the gravel or the media. And these are the two parameters that are the most important, is the hydraulic load and the organic load. This is in the conventional approach of design since now. Now we will see in the source, the pathogens is very important too, but okay. Then for the subsurface vertical flow is very important. The dose and the feeding regime is not the same if we do feeding all the time or how many feeding we do a day, or if we let the filter in feeding or not resting periods. That will change also the pollutant removal. And okay, this is a photograph, sorry, here of some vertical flow constructed wetlands before planting, just to show you that it's very important. Depending on the suspended solid, we will have one kind of material, but we have one kind of another of distribution systems. If we have a lot of suspended solids, we need big distribution systems. If we have a little bit of suspended solids, we can use drip irrigation. I go super fast, but it's okay. Okay. So what is very important is the square meters per person or for animal equivalent. That will be the key point of design of these systems. And more we use combining system. That means that we use vertical plus horizontal or horizontal plus vertical, etc., depending on the target pollutant that we want to remove. Then now this is the new ones that are the intensified constructed wetlands. The new tendencies is to do recirculations to in a little bit of a space to have more pollutant removal, aeration. Then earthworm integration, that's in Toulouse, they are trying this, and this works a lot to put like some another animals to enhance the degradation. Where we have a lot of systems.
It's also to give aeration, no? And
yes.
The worms, they create holes, and so aeration is much better.
And these are the aerate wetlands. Yeah. Here. Yes, that just is a wetland equipped with an air pump that a very, very short, very little amount of energy we use, and it works quite better for removal of some pathogens and some BOD. And what as summary, what does the vertical wetland do? High removal of BOD, nitrification, so we will have nitrates at the outlet, and the suspended solids and a lot of reduction of suspended solid, and the pathogens that depends on the design. We can remove from 1 to 3 logarithmic units of pathogen depending on the design. Here we have the example of the bigger in the world vertical constructed wetlands in Moldavia that is treating raw wastewater directly without any kind of pretreatment, any kind of settling. They do not generate a sludge. So because of this, is a very good system. And is like the Gulf French system. Here you can Google it and you will have a lot of information, because in France, in almost all the little village, they are doing this system to treat the wastewater because it's working very well, and you don't need to treat the sludge. This is the design, okay. And those are the efficiencies of this system. As you see, a lot of BOD, COD, total nitrogen, especially removal of ammonia converted to nitrates. And the area requirements is not like horizontal wetlands, that is 4 or 5. In this case, if to more or less between 1 and 2 square meter per person. And this is an example that we did in Senegal, that we want to use this scheme, but to try to remove more pathogen, like in the zoo. And we see is that if we use more than 80 centimeters of sand, we can reduce a lot more the quantity of pathogens in vertical wetlands. So I think for the zoo, this is important. And these are the performance normally in the vertical flow constructed wetland systems. These are the standard performance. As you can see, we reach, this is from raw wastewater. Raw wastewater after the wetlands. This is the outlet quality, and it's quite good quality, but we have to enhance pathogen removal for the zoos. That's the main idea. And because of this, our prototype now in the zoo of Barcelona, we want to use this advantage of these French systems, but enhance this with some mix of infiltration percolation principles to achieve all the good things that done in these systems, but also more pathogen removal. And I think this is the key factors. So the key message for vertical wetlands for zoo, the material is a key factor. We need deeper filters, maybe aeration, we will see. And maybe at the end, coupling with horizontal wetlands or great technologies if we want to remove almost to achieve potable water quality. And we can think also in a strategy of biodiversity enhancement, like the worms, to do more removal with natural approach also.
Thanks a lot, Antonina. I think you were so fast, so there is some space for questions.
Yeah, that's about the strategy.
If you understand something, yeah,
maybe there are some questions or. If not.
I have one.
Yeah, Tomas has one.
So when it's horizontal wetland combined with vertical, it means that there is some equation between nitrification in vertical wetland to horizontal wetland, or it is not
When
used.
it's vertical plus horizontal.
Yeah.
When it's vertical plus horizontal, it's because we want the vertical for the qualities, but we don't want nitrates at the outlet, so we use for the nitrification. And this is possible if we have enough organic matter. But in the case of zoos, I don't know if it will be enough organic matter. But for urban wastewater, it's a scheme that works very well, vertical.